All right, so good morning or good afternoon or whatever time it is by you. So this is the first lecture video for our introduction to statistics class or Math 110. And we are going to get started this week discussing statistics, what statistics actually are, and what exactly we mean. When we talk about statistics, we're going to talk about data, and we are also going to talk about sampling. So to get us started, just with a definition. So what is statistics? Statistics is the science of organizing, analyzing, and interpreting data in order to make decisions. Now, the key part here, at least what I think the key part is this part here, the in order to make decisions part. And that piece is so important because you can do all of the collecting, organizing, and analyzing that you want to do. But if you aren't making any kind of decision or making any kind of meaningful change, it can be relatively pointless. So, what you'll see a lot of times, especially in social fields, statistics is used in particular to make decisions, right? To make decisions or at least to understand decisions better, right? But that's what's kind of all comes back to. We're stepping outside of the mathematical equations and stepping into a world where we are actually changing things. All right. Now, there are three main ideas when we're talking about statistics, three main segments that this class will be broken into. The first segment that where we have a discussion, the first segment will be a conversation we have about collecting, right? Collecting data. And that piece is super critical. And this will be kind of the first major thing we discuss. If you collect data wrong, everything else you do will be incorrect, right? So that's why collecting data and that whole idea kind of has its own place. The second thing that we're going to discuss is in this class, we're going to discuss descriptive statistics. I'm just giving you an overview of the flow. Descriptive, did I spell that right? Descriptive, yes, I did. Statistics. And I'm going to explain a little more today about what descriptive statistics is. And then also the last thing will be inferential statistics. Inferential, right? Statistics. And these three aspects kind of make up the bulk of the study of statistics. So here, the important thing is data. And here, the important word is descriptive. And here, the important word is inferential. But if we dig a little deeper, it's kind of infer. That's the important word here, infer, right? So these are the three kind of main areas that we'll focus on throughout this entire class, and kind of where we're going to situate the bulk of our discussions throughout the entire class. So let's go back. So collecting data is not actually in these slides, but you can see it here. But this actual week is focusing on collecting data, even though we're jumping right into what is descriptive statistics. So descriptive statistics is basically organizing and summarizing data, right? That's the process, organizing and summarizing data. Now we can organize and summarize data by putting it into a chart or some kind of pie chart, some kind of graph. We can find information like averages, where the middle of the data is. There's a whole bunch of stuff that we can do, but it's basically the stuff that we can how we can describe the data, right? How we can describe it. And that's why it's called descriptive statistics, because we're organizing it, we're summarizing it, and we're putting it in a way that it's easy and legible, and easy to understand. When you look at raw data is so expansive, right? In raw data, is basically data that has not been processed, right? Or has not been like refined in a way that it's easy to understand. So it's unprocessed data. That's what raw data is. And it's just a whole bunch of numbers. It's a mess. Usually it'll be numbers. It's different kinds of data. Could be words, but it's not organized. So it's really hard to glean useful information from it. So that's why we do descriptive statistics, to organize and summarize it so that instead of looking at the raw data, right, we can instead look at a kind of compacted, easier to understand version of the data. Inferential statistics, right, is basically the process of inferring things from the data that you collected, right? Inferring things from the data. So basically, inferring is to draw conclusions, right? Come up with your own ideas, draw conclusions from the data. And that part is like, that's kind of like the meat of statistics, because, you get all the raw data, but, if you just had a raw data, you organize it, it's like, okay, well, where are we now? What do we do with this now? You have to make some kind of decision. You have to infer something. You got to figure something out from your data. And that process of figuring the thing out, that process is inferential statistics. And again, collecting data, which is the first one that we said, collecting data is just the process of collecting the data. How do we actually get the data that we're going to infer things from? How do we get the data that we're going to describe, right? So again, this piece is very important, that the goal of statistics is not just to perform a bunch of different calculations. That's not the goal. Or to use a bunch of different formulas. The main goal is to better understand the data that you collected, right? Better understand the data that you collected, better understand the data that someone else collected, right? Better understand the decisions people are making using statistics and statistical numbers and processes and whatnot, to better understand it. And when you don't understand data, and when you can't understand data, what you allow other people to do is what I like to call weaponize statistics, right? And the reason why I say weaponize is because people will often manipulate different statistics to make them fit a certain narrative, and then they'll use that narrative to pass laws, or to influence some kind of change, or to convince people to do a certain thing. So you're basically turning statistics into a weapon. And if you don't understand statistics, then you won't understand the different things that other people are doing with the numbers, because numbers, believe it or not, numbers are not as concrete as we like to think that they are. A lot of times numbers are much more subjective in the story that they tell. So like the number itself might be objective, but the story you tell about the number is very subjective. So you have to be very careful about that. So we want to understand statistics so that we can understand data. We can understand exactly what's going on and whatnot. That's what we really want to do. So moving on, probability is kind of like the basis of statistics, right? And probability basically deals with randomness, or how random something, or how likely something is to happen. So, for example, if we flip a coin, flipping a coin, we can either get heads, right, or tails. And logically, this tells us that if we were to flip a coin a whole bunch of times, like a whole bunch of times, we would expect the result to be 50-50. That process of expecting something based on what happened, that's basically the idea behind probability. That's the core idea behind probability. We will actually dig more into probability, but just to get this idea here, it's the same kind of thing with statistics, and that's why we base statistics on probability, because if we observe something, right, that gives us clues about what will happen with the future observations that we make, right? So if I look and I see a bird go into a particular hole and bring out a worm or whatever, and I observe that 100 times. When I see a bird come along, I expect it's gonna go in the hole and bring out the worm because I've seen it so many times, right? And that's kind of the root of statistics. So in short, right, we're looking at what happened to make guesses about the future. That's basically what we're using probability to do. Looking at what happened to make guesses about the future. So when we're talking statistics, right, there are two main groups that we need to concern ourselves with. The entire group, right, the entire collection that we're studying, the entire collective of every single member of that collective, we call that the population. Right? That's what we call a population. And in order, because many times it's very difficult to study an entire population, right? Think about it. The population of America is like, what, 300 and something million? It's very difficult to study every single person in America. So what we do many times is we select a sample, right? We select a sample. I'm going to do this a little bolder just because it's so important. We select a sample and we use that sample to study the population, right? Remember what we just talked about in terms of probability? What we're saying is that if we have an entire population, and that's what I'll do, I'll draw an entire population. Let's say each of these little dots is a person. You know, let's actually do this on our notepad. Let's say we have an entire population of a bunch of dots, and I'm going to make all these dots blue. Blue dot, 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 blue dot. Let's just fill this whole thing with some blue dots. So there are blue dots all over the place. Now let's imagine that instead of having however many dots there are, I mean already there are more dots than we might want to count, because yeah, we're likely to make a mistake. Let's just add a couple more dots and then we'll be done. But let's say instead of having to study this entire population, again, this whole thing, the whole blob, is called a what? A population. That's what the whole blob is called. This whole blob is a population. It's a collective of every single blue dot. That's our population. Now, what we want to do, because it's, again, it just is not practical to study every single little blue dot or go around and ask every blue dot. Imagine there are millions and millions of these blue dots. It's not practical to go to every single person and every single blue dot and ask them a question or study them. So what we do instead is we take a sample. Sample is a subset. So I'll do this in red. And instead of studying the entire thing, let's say we just look at these little red colored blue dots. And there are different ways we can space them apart. But I'm just going to color 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I just color 10 little blue dots. Those 10 blue dots make up our sample, right? That's what those 10 dots make up. The 10 ones we colored are our sample. And we use probability to say, okay, when we took our sample, these 10 dots were, had this particular trait or this particular quality. So what we're going to do is we're going to just kind of assume that all the other dots kind of share that particular quality. It's not as simple as that. We're going to go through that actual process of how we do that, but that's the general logic that we're following. We're not going to study every single blue dot. We're just going to study a sample. That word's coming back. We're going to study a sample of the blue dots, and we're going to use that sample of the blue dots to find out information about the entire what? The entire population. Right? That's what we're doing. Using information about the sample to figure out stuff about the entire population. We don't care about the actual 10 blue dots, right? That's not what we care about. Our sample. We don't care about, we're not trying to find out something about just those 10 dots. We're trying to find out something about all of the blue dots, right? That's the end goal. The end goal is to get information about the population. That's our end goal. Get information about the population. And that's a very, very important concept. And it's easily missed, right? That's easily missed. When we start looking at how we collect information, it can be a little bit easy to get stuck on information about the sample because we spend so much time talking about the sample. In reality, we're just collecting information about the sample to use that information to tell us something about the population, right? So that's kind of the whole goal here. So moving on, and this is the same kind of thing that we just drew out, but you see we selected a couple of these little dots, right? We selected a couple of them out of our entire population of blue dots. Now, when we're finding out information about our samples or about our populations, we have two different things. A parameter, right, tells us something about a population, right? In particular, a parameter is a number that is a property of the population, right? That's what a parameter is. A statistic, on the other hand, right, is a number that represents a property about a sample. So one easy way to memorize that: parameter, population, they both start with a P. Statistic, sample, they both start with an S, right? So when we go back to our blue dot example, right, what are we going to find when we find out information about all of these little red dots, which there are only 10 of them, and we're going to ask them some question. Maybe we find out what's the average height of those selected dots in our sample. When we get that average height of our sample, what is it going to give us? That is going to give us a what? Now you can pause the video here and think about it and then come back. But we kind of just said it. So pause the video and then come back in 3, 2, 1. So if you got it, you're a genius. That information is going to be a statistic, right? The information that we find out about our sample will be a statistic. And our goal, and that's going to be a little cool trick that I do, turn my red line into a blue line. Our goal is to eventually turn our statistics into what? Information about our population, which would be what? Parameters. So that's our goal. Our goal is to find statistics and turn them into parameters. That's our goal. And that's what this whole class is almost basically going to be about. How do we find statistics, and then how do we use that to figure out some parameters? And then mixed in there, we will also speak about how exactly we go about making decisions based on those parameters that we find. All right, so moving on, data, right, are basically the actual values of a variable, right? And the word variable just means something that can change, right? So for example, height, I could measure a bunch of people's height. The height is the variable. The variable is height, right? And data are the actual values of people's heights. So the variable is height and data are the numbers, right? So height would be the variable, and then the data would be like 5'9" would be the data. Now, important, data is always plural. Just a little side note, data is always plural. I don't think anyone's ever going to stop you and correct you and be like, oh, you used data wrong in a sentence. But just so that you can know the proper way to use the word data in a sentence, you have to use it in a plural context, because data is a collection of numbers, right? The collection of values. They don't have to be numbers, but They're values. They don't have to be numbers. So now there are two different types of data, right? Two different types of data. So the first type of data is qualitative, and the second type is quantitative. Now, almost all data, we're not gonna say all data. Almost all data can fit into those two types, right? Qualitative and quantitative data. Qualitative data or categorical data, and this word categorical can be your clue, is data that are the result of categorizing or describing attributes of a population. So, for example, if we were to do a survey and we collect people's hair color, right, blood type, ethnic group, the kind of car you drive, or the street you live on, all of those things are describing attributes. So these are categorical, they're qualitative, right? And in general, it's not all the time, but in general, qualitative data are usually going to be words or letters, right? So that's categorical data, the whole category. Now, the other type of data is quantitative data. And quantitative data, we can also call it numerical data, right? And here's a little clue for quantitative data. Quantitative data will always be numbers. Every single time, quantitative data is going to be a number, right? One way to memorize it: quantitative, quantity. Quantity is some kind of measurement of something, right? And we get quantitative data by counting things or by measuring things, right? Counting or measuring different attributes. So we could measure how tall someone is. We could count how much money someone has. We could count how many cars people own. We could count, let me see something else we could count, how many kids someone has. But we would have to measure how long it takes someone to fall asleep on average. We would have to measure how far a certain distance was. So anything we count or measure is quantitative. Now, quantitative data can either fit in two subcategories. They can either be discrete or continuous. Now, just to kind of jump the gun here, for it to be discrete, it has to come from us counting. For it to be continuous, it comes from us measuring. Right? So it kind of depends on which one we're doing. Are we counting or are we measuring? If we're counting, then it's discrete. If we're measuring, then it's continuous. So discrete data, right, again, comes from counting, right? And with discrete data, you kind of jump from one value to the next value with no in between. So for example, when we count 1, 2, 3, 4. We don't jump, we don't fill in every little fraction in between 1 and 2. And even if we count on a smaller scale, we would count 1.1, 1.2, 1.3, 1.4. Doesn't matter how small the scale is. If we are skipping space, because in between 1.1 and 1.2, there are a bunch of small numbers. If we're skipping spaces like that, then it is discrete, right? Another way to think about it is just if you count it. If you count it and you go 1, 2, 3, 4, right? Or you count it and even if you go in halves or something, if you count it, then if you can count it, then it is discrete. Now, continuous data is from measuring, right? So when we measure something, right, it's continuous. So for example, you would measure a weight, right? That would be continuous. You would measure a height. That would be continuous. Usually amounts of time are continuous because it could take any value, right? Usually distances are continuous. Any distance, right? Anything that you measure, you got to pull out a stopwatch, measure how fast something goes, is continuous, right? You got to pull out a ruler, measure how long something is, it's continuous. So that's the difference between continuous and discrete data. All right, so let's talk about variables and the different kinds of variables that we can have. So we already said that variables could be quantitative or qualitative, right? And depending on what they're doing or what they're measuring, right, or what attribute they're describing, right, that's how we'll know whether they're quantitative or qualitative. And if they're quantitative, then they can be discrete or continuous. Now we're going to introduce one more idea here. And that idea is basically explanatory and response variables. And we're going to come back to this like very, very far later in the class. But basically, if we think that one thing might cause another thing, then the thing that we think is causing it is an explanatory variable, and the thing that we think is changing based on the other thing is a response variable. So, for example, let's say we had some theory, we measured people's foot size, we measured how tall they were, and we had some theory that shoe size, right, was somehow proportional to height. And somehow, if you had a bigger shoe size, you would be taller, right? Then we would call shoe size the explanatory variable or height the response variable. And I mean, it kind of depends on how we're looking at it, because if we wanted to say that your height causes you to have a bigger shoe size, then we would flip them around, and then height would be the explanatory variable. But I think it's pretty straightforward when we talk about that. When we talk about explanatory and response variables. Now, continuing on with our variable discussion. So we already broke it down. There's all variables, and we broke it down. Numerical was what again? Numerical was quantitative, right? And categorical was qualitative. And we already broke down the quantitative data, right? We broke down the quantitative data, and we already said that quantitative data could either be continuous or discrete. What we're going to do now is we're going to break down qualitative data or categorical data. And categorical data can fit in one of two categories. Yeah. See what I did there? It can either be regular categorical or ordinal. So regular categorical data cannot be put into a meaningful order. And it's keyword, cannot. So you can't order it into any order that makes sense. So for example, colors. Let's say we have colors red, blue, green, yellow. Is there an order that makes sense? I mean, clearly this is categorical data. Let's say we were describing people's hair color. Red, blue, green, or yellow is clearly a word, and is describing some attribute. So this is categorical, and we can't put it in an order. Who's to say maybe blue goes first? Maybe green goes first. Maybe yellow goes first. Maybe red goes in between blue and green. Maybe blue goes in between green and yellow. There's no meaningful order we can put it in. So it is regular categorical. And then we have ordinal data, which is just like the opposite, where we can put the data into a meaningful order. So we can put it into a meaningful order, and the key memory tool that you can use, order, ordinal. So order kind of sounds like ordinal. They have the same little root, O-R-D, ord, right? So that's what, an example of categorical data that we could put in an order would be grades in a class, like letter grades in a class, A, B, C, D, and F. And when we look at this, there's a clear order. F is at the bottom, A is at the top. A is first, and F is last. F is the lowest grade, A is the highest grade. So we can put it into a meaningful order, an order that makes sense, right? And another way that we can classify data, besides just classifying it in categorical and quantitative, or qualitative versus quantitative, ordinal, all that. Instead of that, we can classify data by looking at the level of measurement that the data is at. Right. So we have 4 levels of measurement. We have nominal, ordinal, interval, and ratio. Nominal level of measurement, right, is starting off with qualitative data. So it's names, labels, categories, and we can't put it in some kind of order. So we could also call the nominal level, we could call it regular categorical, or regular qualitative, regular categorical. So we could also call it that. Then we have the ordinal level of measurement. And the ordinal level of measurement is basically qualitative data that we can put in order. That's the ordinal level, like letter grades. So this would be basically ordinal categorical. And then we have interval. The interval level of measurement is data that can be arranged in an order, but when we subtract, right, it can be arranged in an order, and we can subtract and find differences between the values that are meaningful, but there's no natural starting point, no natural starting point, no natural zero. And an example of that would be years. There is no like year zero. I mean, yes, you could say that year zero, but year zero is not the beginning of time, right? That's just how we did it, humans. But it's not the beginning of time. It's not really a natural starting point. And you do have years before year zero. You have BCE, that's before Common Era, right? So that's the interval level, right? We can put it in an order. We can find differences that are meaningful, but there is no natural zero starting point. For a lot of these, you just kind of have to make note cards and kind of study it like that. I know it's a lot, but you just kind of have to make note cards. And then lastly, we have the ratio level. In the ratio level, we can put it in an order. We can find differences, and there is a natural zero starting point, right? And that natural 0 point, again, is basically the point where none of the thing are there, right? Where there's none of it is present. The quantity is 0, right? So moving on, kind of summarizing it, we have nominal, ordinal, interval, and ratio, right? Here's a little example we can do to kind of help us out. So let's say we conducted a survey on some students in Introductory Statistics course. And here are some questions on the survey, and here are the corresponding variables that we got back. So we did gender. Are you an introvert or extrovert? That's what that should say. Not what is your gender again. It should say, are you an introvert or extrovert? So introvert or, that's what it should say. How many hours of sleep do you get? What time do you usually go to bed? Countries, how many countries have you visited? And dread, how much do you dread being in this class, or in this case, watching this YouTube video? So starting off, gender, what would you all guess? Is that, well, actually just kind of look through all of these and see if we were in class. I'd like call on people's names, but we aren't in class. So which one would you guess? Look at all of these, pause the video, and take a guess as to what you think each one of those variables will be. What category will they be? Will they be qualitative, quantitative, nominal, ordinal, interval, ratio, discrete, continuous? Will they be regular categorical, or will they be ordinal? Right? Look at it, try to sort each of these different variables. Think about what responses you would get. So for example, countries, how many countries have you visited? What response are you going to get when someone asks you that question? So pause the video. Uh-oh, I kind of went to the answer already. But pause the video, and then come back. Pause it, write out what you think is the answer, and then come back. So we're gonna go forward in 3, 2, 1. So moving forward, this is how we collected the data. Like this is our raw data. We made a big old spreadsheet. It's our raw data. Notice when we have our spreadsheet, and we're gonna look at Excel a little bit more, but notice the top row of our table is basically the names of the variables. And then going down is the different values that we got for each person. And each row across is an individual person. So that would be student 1, right? This would be student 2, student 3, student 4, all the way up to student 86, right? And then this is what student 1 said for their gender. This is what student 2 said for their gender. This is what student 3 said, so on and so forth, right? So let's look at the answer. What do we get? So for gender, we got categorical. I mean, that one kind of just makes sense, and it would be regular categorical, right? Let's put a little comma and put regular there. It would be regular because there is no meaningful order we could put gender in. Who's to say male goes first? Who's to say female goes first? No meaningful order. So for gender, it'd be regular categorical. For sleep, it'd be numerical, and it'd be in particular continuous. And it might be discrete if you were just counting like 1 hour, 2 hours, 3 hours. But it would be continuous if you were like doing a timer to measure how many hours of sleep a person got. So it's numerical. Again, we said numerical could also be called quantitative. And for bedtime was what time do you usually go to bed? That is categorical, and it's ordinal. It's categorical because the time you go to bed is not let's go back. Let me see exactly what the question was. Yeah, what time do you usually go to bed? The time that you go to bed, it's not really well, how can I say this? Like a time. I mean, honestly, this one can kind of go both ways depending on how you look at it. But the time that you go to sleep is not really because the numbers kind of stop. So each hour is kind of a different set period of time. Like it's a little difficult to explain, but honestly, this one could go either way because it's numbers, but at the same time, it is kind of like putting you in a category. I think the reason why they did categorical for this one is because I don't think they did like say your exact time. I think they gave a like a bracket of times. So they said it says 10 to 2, 12 to 2, 10 to 12, 12 to 2 for the time that you go to bed. So any time between those hours. So that's why it's categorical. It's not asking for the exact number. Number of countries is numerical or quantitative. That's because you're counting it. And it's going to be discrete because you're counting it. You're not measuring it. And then for dread, even though it's numbers, it's categorical. For this one, it's like rate your pain from 1 to 5, right? I mean, 1 to 5, like one of these numbers doesn't really mean anything else. It doesn't really, like, it's kind of a subject. It's like saying I'm really much in pain or I'm only in a little bit of pain. Right? It's not really, like it's not actual numbers. They're just using numbers as like a placeholder for words. But the useful thing about doing a scale like this is because when we do a scale like this, we can actually work with those numbers as if they were actually quantitative. So we actually have to deal with quantitative and qualitative data differently. But when we do have numbers for categorical data or qualitative data, we can sometimes work with those numbers as if they were numerical. So moving on, hopefully you got all of those correct, or at least you were on the right track, thinking the right thing. But let's move on. So let's look at this one. What type of variable is a telephone area code? So area code would be like 202 if you from DC, 202-111-1111. I don't know if y'all thought I was actually gonna give you my number, but no. This is the number we go put here. So 202-111-1111. The area code is this first part in the beginning. Tells you what area you're from. So pause the video, take your guess. We're gonna come back in 3, 2, 1, and the answer is categorical, right? So you may have thought that this was numerical because 202, it's numbers. I mean, that's an area code. But when you think about it, 202 is a number, but it's not really a number. Like 202 versus 301 is one better than the other, right? I mean, yes, I will tell you 202 is better than 301, but I mean, is one really better than the other? Not really. Is one higher than the other? Can we put it in any kind of order? No, we can't, because they're area codes. They're like categories. It's describing where you are. It's not counting anything. It's not measuring anything. Whenever you see numbers, just ask yourself that question. Is it counting something? Is it measuring something? If it's numbers and it's not counting or measuring anything, then it's going to be categorical or qualitative. So moving on, we're going to skip past this example. We'll probably do this example when we actually meet in person or online. We're going to skip past this example here. All right, so what we're going to move into is we're going to move into our discussion on different types of sampling methods, different types of studies that we can do, and different kinds of sampling methods that we can look at. And again, sampling, right? Sampling is that process of picking out which of those blue dots we're going to look at. That's sampling. So sampling is picking out, how do I know which blue dots to actually take to be my 10 blue dots that I take as a sample. Okay, so that's what we're going to discuss now. I'm actually going to do this part in a new video just to kind of make it a little more manageable. Let me see, what time are we on? Yeah, so we're going to do this in a new video.